We have a really short set of notes for lesson 6.3 on linear functions. You just finished an entire chapter on linear equations. So we're just going to add one piece in this section that will lead us into chapter 5 on systems of equations. The definition for a linear function is very similar to a linear equation. It is a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So all of that is the same, except for the idea of a non-vertical line. So when you were graphing equations, you could have a vertical line, x equals 3, and that would be an equation. But you can't have a vertical line as a function because a function can only have one y value for each x. So it can't be a vertical line. That's the only difference in the definitions. So we are going to be comparing linear functions. They have a little problem here. The earnings, y in dollars, of a nighttime employee working x hours are represented by the linear function y equals 7.5x plus 30. So they give the nighttime employees information here in the equation. And then the table shows the earnings of the daytime employee. Okay, and then they're going to ask you to contrast those two things. So we can see when we're reading about the daytime employee that as the hours are going up by 1, that the wages are $12.50 and then $25 and $37.50 and $50. So they are going up by $12.50. So the first question asks you which employee has a higher hourly wage. So we can look at the nighttime employee. And the equation of that line, or of that function, is y equals 7.5x plus 30. And you can see by this equation, here's the slope, that this employee is making $7.50 per hour. Notice the difference between when it is the slope, I can write it as 7.5. But when we're talking about money, then we need to be sure to put the 0 on and call it $7.50. 7.5 is not money. Okay. Another thing to notice, I tell you that slope is almost always a fraction. I want you to write it as a fraction. I don't like you to change it to decimals, except if it makes sense in the context of the problem. Here's one where it makes sense in the context of the problem. Because we're talking about money, it makes sense to write the slope as a decimal, where normally we write it as a fraction. Okay, what do you think that 30 is? Why is the y-intercept not 0? I think that they probably pay a nighttime employee a bonus for coming in and working at night. Okay, it's an extra bonus for being a nighttime worker. Then we'll contrast that with the daytime employee. So we can find that slope by finding the change in the y over the change in the x. And the book so handily did that for us. They showed us that the y value is changing by $12.50 per the x value is changing per hour. So the daytime employee is making $12.50 per hour. So the daytime employee makes more, but they don't get that $30 bonus. So the next question asks you to write the function that goes with the daytime employee and then to graph both of those things in the same coordinate plane and interpret the graphs or tell what's going on there. Okay, so it's pretty easy to just write that one as y equals 12.5x, and then there is no y-intercept. This is a proportional relationship that will start at 0. Okay, let's do the nighttime employee first. Let's draw our graph. So we're going to put hours on the x and count by ones. And we'll put earnings on the y-axis in dollars and count by 15s. You just have to do kind of a little guess and check to figure that out. I used the book to give me a nice scale. All right, I think that'll go far enough. All right, and so when we want to graph, I know that I'm going to start at 30. That's the y-intercept. Let's start there. And then I know that my slope is 750, so I'm going to go over 1 and up 7.5, over 1, up 7.5. 7.5 is a little awkward on here. Why don't I go over 2 and then I can go up 15? So instead of graphing 750, I can graph $15 if I go over 2 hours. So in 2 hours, I would go up to 45. And in 2 more hours, I would go up to 60. And in 2 more hours, I would go up to 75. It's easy, so I'll go over 2, go up 1 more. And then draw my line. Okay, actually, let's label that one while we're there. Then my daytime employee starts here at 0 because it's proportional. And I'm going to do the same thing. I'm going to graph it by $25. So I'll go over 2 hours and up 25. For 2, and there's 20, 25, so it's about 2/3 of the way up. And then if I go over 2 more hours if they work for 4 hours, they would make $50. So that's getting close, almost ready to overtake them. And then in 2 more hours, I would be at 75. So that's the crossover point. And in 2 more hours, I would be up to 100, which is there. Okay, so when we move into chapter 5, this is what we're going to be doing. We're going to be looking at 2 equations and looking for the point where they cross. That's called the solution for a system of equations. This is the point where the daytime person and the nighttime person made the same amount of money. So when it says to interpret the graphs, you can say the nighttime person starts out making more. Nighttime employee starts out ahead, maybe by $30. But they make less. Their slope is lower. Is that the right word? Is it less? It's less steep. So the daytime employee catches up at 6 hours. So less than 6 hours, the nighttime employee makes more. Their line is on top. And at the 6-hour point, then the daytime employee makes more total. There is one you try on the back. How does it look like? And it's very similar. You've got a manager earning $15 an hour with a $50 bonus, and the graph shows manager B. So you'll have to compare the two.